So now, as part of your homework, you are told to complete question 4. So question 4 says that, oh, you are supposed to find out how many terms there are in our negative 4pq minus 3q cubed. So let's check our answers. There will be 2 terms over here. And what are the terms? They are negative 4pq cubed. So the term includes the number in front of it. What is the name of this number? Starts with C. Coefficient. The coefficient includes the sign, which in this case is negative. So the other term is negative 3q cubed. Okay? So these are the 2 terms and the coefficient. Coefficient of something. It is always coefficient of something. In this case, it is coefficient of p q cubed. The coefficient is a number. Okay? Our p, q over there, they are variables. We can substitute in numbers that we like. So over here, the coefficient is negative 4. It includes the sign. So likewise, coefficient of q cubed is negative 3. These are the 2 coefficients. What is the constant term? Oh, there's no constant term. There's no constant. A constant looks like this. A number by itself. If I really want to squeeze out a constant, the constant is 0, which is the same as no constant. Right? So I don't bother writing it. Okay, next one. Question 5. Number of terms, how many are there? Oh, I see 3 of them. They are x squared. We've got 5x. Do I need to put a plus in front of the 5x? No need. Positive, we don't need to write. And the last one, we've got negative 6. So the coefficient of x squared is, oh, what is the coefficient of x squared? There's no number in front. Is it 0? Why can't it be 0? There's no number. Why can't it be 0? See, we've been saying that the coefficient is the number including the sign in front of the variable. So why can't it be 0? I don't see a number over here.
X is 1.
What do you mean x is 1?
It's 1 number.
Okay, you are telling me that the coefficient is 1, is that it?
Yes.
Why can't it be 0?
Because cannot complete the equation.
I know the answer is 1. You may know the answer is 1, but why can't it be 0? Yes, John? What were you saying? Okay, because if our coefficient of x squared is 0, then 0 times x squared is 0. Then there's no more x squared term, right? So it cannot be 0. In fact, there is an invisible 1 over here. And the coefficient of x squared is 1. So coefficient of x is 5. And finally, our constant term is negative 6. Is 2x and 2x squared the same? Are they the same? No, okay. Give a reason. 2x is 2 multiplied by x. 2x squared is 2 times x times x. Okay? I'm too lazy to spell out the word multiply so many times. Then I use the symbol, multiplication symbol. But if you don't write your multiplication symbol differently from your x symbol, then it may look like this. 2x squared equals to 2 times x times x. Wow, what is this? What does this mean? So you see, if you write it this way, you cannot tell what you're writing. That's why right now, from Sec 1, we practice writing x this way and multiply this way.
Is there another way, right?
As long as you make it different from your multiplication symbol, I'm okay. Okay, next one. Exercise 1 is also your homework question. Ms. Tan has already gone through part A and B, number of terms. So part C, quite clearly, number of terms will be 3 as well. Write down the variables present. So variables in this case will be all the unknowns, things that we can substitute with numbers. So in this case, we've got first variable x, y, z, x squared y. Okay? Next one. Okay, this is where I thought Miss Tan asked you all to do this also. She said do until page 3. Right? So you're supposed to do exercise 3, So listen to the instructions carefully. Okay, now, in the following algebraic expressions, these over here are expressions. All these are expressions. Write down the coefficient of variable and the constant term. So the variable over here is x. The variable is the unknown. The coefficient is 3. The constant is 6. Okay, can you all give me the answer for the next variable in part B? A, good. Coefficient? 1/4 and the constant? -12. We must have the sign. Okay, the sign that is stacked along with the 12. Okay, next one. We've got variable c squared. What is the coefficient? What is the coefficient? 1. Variable, next one. D, coefficient 9. Next one, E. Is it 4 or -4? -4. Constant term? None. Or you can say 0. Okay, that is our constant term. 0. It's nothing. Constant term has no variable. It's just a number by itself. Okay, next one. Like terms. So early on, we've been talking about terms, coefficients, variables, and constants. Today, we'll look at what are like terms and what are unlike terms. Like and unlike. Have you ever come across these words used in other contexts before in mathematics? When? Primary school? Like poles and unlike poles. Oh, you learn about like terms and unlike terms?
Yeah. But different concept.
Okay, it's okay. We'll learn now. Basically, right, as the name suggests, like terms are terms that look like each other. Okay, I'll elaborate. So, specifically, we'll say that they have the same variables. Okay, maybe one, maybe more. Same variables. Unlike terms, will not have the same, so different variables. Maybe one, maybe more. Okay? We need examples. Let me show you exercise 4 first. You see the whole list of numbers over here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. 12 terms. You see 12 terms? Very messy, right? All messed up already. Are there any terms which have the same variables? Okay, so let's start with the easy one over here. All the B terms. How many B terms do you see? We've got 8b and -9b, right? They have the same variable. The variable is b. They are known as like terms. These two are like terms.
B cancel each other.
They don't cancel. We are just grouping them together. We're just grouping like terms. The terms that look like each other. What is the definition of look like each other? They have the same variables. So of this list of 12 terms, only 2 of them have just b by themselves. So our 8b and -9b, we call them like terms. Okay, next one. Let's take a look at our y square x terms. Y square x as well as xy square, are they the same? Let's check out. Y square x means y times x. Well, our xy square means x times y times y. Are they the same? Yes, they are the same. So these two terms are like terms. Look at the highlighted green color part. I'm highlighting to show you they are the same. Therefore, these two we done already. -4/3 y square x as well as negative 9x y square. They are like terms. We put them together. Okay, next one. We've got our x square y terms. So x square y means x times y. We have 8x square y, negative 3x square y. We have negative x square y. So can you see that these are all the same? I mean, they are like terms, same variables. And finally, we have our constant terms. Constant terms have no variables, right? They're just a number. So listen carefully to what I'm just going to say. Constant terms have no variables. Does that mean that they have the same variable? Listen carefully again. They have no variables. Does it mean that their variables are the same? Yes, in a way, because they all are the same. They have no variables. So as long as you see a number, 1 and negative 2, these are examples of like terms. Yes, I can include more numbers, right? It can be, for example, 0.3 recurring. This is also a like term. I can have square root 2. This is also a like term. These are all constant terms, no variables. So we could have placed them in here if it is part of the list. Why it's not part of the list, I will not confuse you. Okay, so far? Okay, then now I've got 3 more terms that were not included in the list. Does our 8x go anywhere? No, there's nobody else that is like 8x. X is the only term. So no, it doesn't fall under any like term. 5ac, does it fall under any like term? In this case, nobody else looks like it. What about our 7yx squared? Does it fall somewhere? Where? Which color? Yx squared. Which color? The blue one, right? Okay, so let us include it over there. Let's include it here. 7 yx squared. Okay? Because yx squared is the same as y times x times x. Our x squared y is x times x times y. The same thing. Now we can go back and answer these questions. Are all constants like terms? Are they all like terms? Yes, they are. Do x, y, and yx have the same variable? Yes, again. Because, okay, this upside down triangle over here with 3 dots means because. Okay, so because I can give you an example. 2 times 3 is the same as 3 times 2. It's the same, whether we arrange it one in front of the other. It's the same. Now, negative 2ab and negative 3ba, are they like terms? Yes, again. We consider, what do you mean? AB and BA, they are the same. What do you mean by group them? What do you mean? Why is the result the same? We still have 6 people. Okay, so Samuel is suggesting that 2, sorry? What 2? You were saying 2 people in 3 groups, right? In 3 groups each. Am I right? So you have 3 groups with 2 people in each group versus 3 groups, 2 groups of 3 people. Okay, so this is his example that he's giving me, and he's trying to tell me that, hey, they are different. In English, they are different, right? In English, one is 3 groups, the other is 2 groups. In English, the one that has 3 groups has 2 people each. The one in 2 groups have 3 people each. But in mathematics, do we have the same result?
Yes.
Yes, we do. 6 people altogether. In mathematics, they are the same. That is why these 2, we will consider them as like terms. Okay? Moving on. Addition and subtraction. Okay, this one will come quite intuitively because you are very used to addition and subtraction of numbers. Today, we are just going to include algebra in there. It is the same as your primary school algebra that you have learned. Okay? And we always go back to, for example, 3 apples minus 1 apple. How many apples left? 2. In full, we call it 2 apples. Change all the apples to x. 3x minus 1x, you get 2x. That's it. Okay? So let's start with this. Oh, by the way, can you add 1 apple to 1 orange? And you get 2 something? Can't, right? 1 apple plus 1 orange equals to 1 apple and 1 orange. You cannot put them together. They are unlike terms. Get it? Okay. So to do our addition and subtraction, say apply your BODMAS, rearrange such that put all the like terms are together. Imagine I tell you 3 apple plus 2 orange plus 5 apples plus orange plus apple. We group all the apples together, we consider how many apples altogether. Then we group all the oranges together, we consider how many oranges altogether. Say. Okay, so 5a plus 13a. Answer? 18a. But b. 5b minus ab. Can or not? 5b minus ab. Small number minus big number. Can? And you just get a negative number. Negative 3b. Wow. 2by minus 9by plus 6by. Are they all like terms? Are they all like terms? Yes, they are. So you can treat this by, you can treat them like an apple. It's the same thing, right? So we got 2 of them, minus 9 of them, plus 6 of them. Answer? Negative 1by. Will you leave your answer like this? Will you write it like this? What will you write? Negative by. There is no need to write the 1. Okay, next. Part D. What is the answer? 6, 7. Done? Mental sums done already? How much? Negative 2m. Very good. Part E. What is the answer? Group all the like terms together, huh? So we can rewrite it this way. 3n minus 4n plus 10 minus 11. This is called grouping and rearranging. I group all the like terms together. So 3n minus 4n, what do we have? Must we say negative 1 or can we just say negative n? Negative n. Then minus 1. And the last one? Last question? 1 minus k. Do you all have that? Did anybody have negative k plus 1? Are they the same? Yes, they are the same. Okay, we've got a few more. 5c minus 4d minus 3c minus d. Let's try this. Are you able to group all the like terms in your mind or do you need me to write them out for you? Can do it in your mind? Okay, how many c's do we have? How many c's? 2 c's. Okay, how many d's do we have? How many d's do we have? Wrong. 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 How many 5's do we have? Negative 5d. Okay, so rewriting this, it actually looks like this. 5c minus 3c. I am writing minus because the coefficient of this c that I circled is negative 3. The coefficient includes the sign. So if this is 5c minus 3c, then minus 4d over here and minus d. So you can group everything together first if you like, if it makes things easier for you. Otherwise, this is what we have. Okay, h. Are you able to do it in your mind or do you want to rearrange them first? Because we don't need to write negative 1. Okay, so negative az plus negative
and negative minus 9x.
Can do it in your mind?
It's not negative, it's minus. It's minus.
Whoa. what you're arguing about? Whether we call it minus or negative, is it? Do you know there's a slight difference between negative and minus? When how do you read this? How do you read this? This is known as negative 9. But if I have wait, then how do you read this? Negative 9 minus 1. When the negative sign is at the start, we call it negative. But if it is somewhere else in the middle, we call it minus. Okay? But when we have things like this, negative 9, how do you read this? Yes, correct. Is it very important? No, it's not very important. You know how to use it, can already.
Ouch.
Okay, next one. Part I. Answer? Negative 3y square. 2xy. Okay, 2xy is by itself. There are no other like terms. Okay, final question. Aloysius, you don't answer. How about the rest? Hey, I asked you not to answer, right? Give others a chance. How many r square? 6r square. Minus? Minus? Oh, there's another r at the back. Okay, so do you want to do the r first or do you want to do the constant first? It's up to you already. So since I wrote minus already, then can we do the constant? Minus 3, then plus r. Okay, this is accepted. But if you notice, no, this is already simplified. Yes, this is already simplified. If you notice, usually as you progress, you do more mathematics, you notice that we like to arrange them in a certain manner. We like to put the square term in front, 6r squared. Then we like to put the next variable, which is plus r. Then we like to put a constant right at the end. It is a habit. By the time you go to Sec 4, you will have this habit also. Okay, it is a very useful habit for us to compare things really quickly. Okay, so I prefer you to write it this way, but this is also correct. They mean the same thing. Yeah, it's neater. Okay, today we are bringing you back to primary 2. Is this primary 2?
Primary 3.
Primary 3? No, I think primary 2, right? 3 over primary 3, okay, primary 3. 3 over 4 plus 2 over 3. How much is that? Have you been using your calculator for this type of question? Okay, so what must we do? Fraction plus fraction. Denominator must be the same. Shall we have 12 as the denominator? Yes. How do you know it's supposed to be 12? Can we have 24 as the denominator? Lowest common multiple, yeah. Where we covered that in chapter 1 also, right? Lowest common multiple. So this will give us, and I want you to write it this way. I have a habit. My habit is I like to put brackets around all of them. Then I multiply this by 3, multiply by 3, multiply by 4, multiply by 4. There is a reason why I like to put brackets, because later on they get a little more complicated. Okay, so we will end up with 3 times 3 over 12 plus 2 times 4 over 12, which gives us 9 plus 8 is, 9 plus 8 is 17 over 12. Okay? Then the next thing you need to know is that, hey, b over 6 is the same as 1 over 6 times of b. Have I covered this before? Yes, and this is particularly crucial because you need to recognize that b over 6 and 2b, they are like terms. Can you tell that they are like terms? It may not be that obvious, but once you change my b over 6 to become 1 over 6b, you compare it with 2b. Do they look more alike now? Yes. So you need to recognize that b over 6 is the same as 1 over 6b. in order for you to group all the like terms correctly. Question. How will we rewrite a over 5? 1 over 5 times of a. Okay? Then everything else is the same already. Let's move on. Exercise 6. Simplify the expressions. Means you add them up. Okay, what is the common denominator? Shall we use 24? 12? 12. Okay, let's use 12. So like I said, I have a habit of putting brackets. I think it is a good habit. Then I put out multiply by 2. You said it was 12. So top multiply by 2, bottom multiply by 3, top multiply by 3. Let's see what we end up with. This is 2 times of b over 12 plus 3 times of 3b. How much is that? 9b over 12. And we get 11b over 12. Are you learning something different? Or is it just a little bit more than your primary school maths? You learned this in primary 6? I'm quite doubtful. Okay, 5x over 3 minus x over 3. Really? Is he correct? What's the answer? 4x over 3. The denominator is the same already. Okay, what about this one? Hey, are they in like terms? Is my x and negative 2x over 3, are they like terms? What is the coefficient of the first x? What is the coefficient of the second x term? Is it 2 over 3 or negative 2 over 3? Negative 2 over 3. So you've got 1 apple minus 2/3 of an apple. What is the answer? 1/3 of an apple. 1 over 3x. Or we can write it as x over 3. But if you want to do it mathematically, right, wow, this will become x over 1 minus 2x over 3. Make them the same denominator, 3x over 3 minus 2x over 3, and you get x over 3. Right? Same denominator, right? Isn't this what you will do? But if we look at it this way, 1 apple minus 2/3 apple, straight away get an answer already. Okay? So please go back, watch the video. The video, I checked the video, and it ends with you. Wow, that's really a lot, huh? Maybe we should reduce it. Okay, let's do until exercise 10. So I don't need you to do everything. Okay, so stop here.